Hi, I wanted to take a few minutes to demonstrate automating the build out of an ACI fabric. I generally like to split up the ACI fabric build out into these high-level steps. The two steps that we'll focus on here today will be the step that configures all the fabric constructs, and those are typically divided into two subsections, if you will. One, to configure the access policies, all the things you need, CDP, LLDP, 10 gig, 1 gig, all the things you need to provision an interface. You want to think of it that way, VLAN, including VLANs. And then the fabric policies, which are literally just how the whole fabric as an entity behaves. Things there include NTP, SNMP, a route reflector, those kinds of things. And then all the items you are probably sick to death hearing about regarding ACI. Endpoint groups, so EPGs, bridge domains, application networking profiles, those things. Let's look at what it might look like, or what it does look like, to actually automate those two steps. So starting with our access policies, let's take a quick look, and I want to show here that this is essentially an unconfigured fabric. It's obviously deployed. We can get to the apex via management, but really there's no tenants but the three that come standard out of the box. If you go to the fabric, start taking a look at the access policies, you'll see there's very little configured. It is one of our test fabrics, so you'll occasionally see something odd. But in general, not a lot here. No VPC domains, this test protection group. And then if we go to fabric policies, generally day one, the predominant thing you worry about in the fabric is the pod policy, and there it's SNMP, NTP, and then the route reflector. And I can see here that some of these are actually configured, and so I'll actually illustrate one of the capabilities of these scripts, in that not only will they create the objects, but they will also delete them. As you can see there, we just lost the date and time policy. You may or may not have noticed, but the route reflector actually had nodes in here, had an autonomous system set. So let's go ahead and take a look. The script is fairly simple. You pass it a JSON file with the payload that you want to instantiate or remove, but usually instantiate on the fabric, and then a key telling it either to create it or delete it. Since we just deleted it, we're going to go ahead and set that to true. And you'll see a variety of things that popped up. We now have our NTP, or our date and time policy. Two servers are part of that policy. It is enabled. There's a description in here. If you go to the route reflector, you see now that it does actually have two switches in here. It has an autonomous system number. It has a description. You'll see that there's also a policy group where there wasn't one before, and the policy group references our NTP policy. It actually also references our BGP policy, but the BGP policy that we updated was the default one. And so this is actually doing what we wanted to do, although it may not look that way. So it is important to look closely and to understand what's been set to default. Technically speaking, we could actually set the time here. And that's a bit of a judgment call. In some cases, if there's a need to change things, I like to create a discrete policy so that users will know that, I change NTP here. It is unlikely that you'll go in, or that a user would go in and start manipulating the route reflectors. That's one of those things where you turn it on and you never really think about it again. And so that's why that one I configured using the default object. So our fabric policies have been configured. Now let's look at our access policies. And again, we already looked at these, but I like to open these up so it's clear where things changed, where they didn't. And the script to build out the access policies is very similar to the fabric policy script. You actually pass it almost exactly the same thing, obviously different payload. In this case, we're going to pass it a JSON file called test ACI constructs 3, and we then pass it the true parameters so that the script will configure versus delete. And as you can see, many things popped up. And if we take a look, if we look at our VPC domains, you can see that we have VPC domains configured and protection groups. And every time one of those files runs, it will create a log file. Let's take a look at this one just very quickly. And it tries to describe at a high level what it wanted to do. In this case, the user admin is creating the configuration on this APEC. It's using the payload or the data, the configuration data from this particular file. And these are the actions it took. So it set the autonomous system number to 65500. It added a description. It added these two switches as route reflectors. You get the idea. And then it tells us if it had an issue or not. Let's go ahead and run this again. And let's take a look at the resulting log file there. Just to give you an idea of why that particular log file can be important. And you can see here that we had a different outcome this time. But if you start reading the error text, it's all errors because the constructs already exist. And then of course it always ends with the execution time. This is where the switch comes in very handy. And you can see now that all of our error status codes were okay. And if we create again, you can see that they're all okay. And this is just outputting to the screen what gets logged in the timestamp log file. Okay, so we have our fabric policies configured, our access policies configured. And let's go down, because one of the things we did configure were the pools. And you can see that we do have 2 pools here. So that part's done. And it took the scripts, let's call it 10 seconds collectively to run. So the final part, let's go back to our tenants. The final part would be to configure that third item, the network and application constructs. So we'll just leave our screen there. Now this is a less sophisticated script if you want to think of it that way. It's standalone. You actually take the data that you want, usually start out with those configurations in Excel, and then there's a couple of ways that you can, a couple of tools, and there's actually a script here, CSV to JSON, that will take a comma separated value and turn it into a JSON data structure, which is what these programs require. So if we run this one, no parameters, again the data is actually in this particular program. That's not a best practice at all, and we'll be working to update that. But for now, it gets the job done. It's clearly not as pretty, but you can see that a new tenant popped up. And if we read just the file here, we know that we're working on 2 tenants, the common tenant, which is one of the default tenants, and then we instantiated this brand new production tenant. We also are working on a new application profile called ESX server. And then these are the things that got pushed to the common tenant. and it's difficult to read. It's certainly not as pretty, but we'll take a look at the GUI in a minute. You can see what actually took place. And then here are the things that got pushed to the production tenant. So in common, we'll take a look. And in this particular design, what we wanted to do is create all of the subnets and the bridge domains in the common tenant. And so let's look at networking. And we would expect to see kind of our corresponding VRF or private network, and it is there. And then let's look at the bridge domains. And all these bridge domains, I would expect to all reference that VRF. And let's take a look and check out the subnets, and sure enough, we have subnets configured. The other thing to note is that this script, the way the payload data was constructed, actually enabled customized flooding behavior on all of these bridge domains, which means it's behaving very much like a traditional VLAN versus the optimized flood and learn behavior that ACI has. But that's you generally want to turn off the optimized flooding behavior if you think this VLAN is going to essentially get extended out to the legacy network. Okay, so that looks like what I had expected. And then if we go to our tenant, so we did the networking, the bridge domain, and the subnet constructs in the common tenant. And the reason for that is so that if we should ever need to build out another tenant, we could actually leverage those and not have to do VRF route leaking and those kinds of things. But the things that are more application oriented, we set up a new tenant and put all the application information there. And so you can see that there's our application profile. You can see all the EPGs. The naming should be very clear what maps to what. And so this ESX SIFS EPG, if we look at its characteristics, it's using the common CSF bridge domain that we configured in common. So that is essentially steps 2 and steps 3 of an ACI fabric build out. Step 2, all the fabric and access policies. Step 3, all of the networking EPG bridge domain constructs. So that took us, let's call it, with me talking, about 10 minutes. And so next would be to configure the host connectivity constructs, all the hosts that are going to essentially connect up to the fabric. And then the last one, usually the most customizable one, because this is where this fabric is talking to an existing network, and it can take many forms. And I generally think of it this way, not just because this is how you wind up doing it, and the order in which you wind up doing it, but also it gets very generic to very specific. And so the next demonstration will focus on host connectivity and layer 2 and layer 3 links. Thanks a lot. Bye-bye.